What do I don't know how to use it.
Oh, the
the
slideshow.
Thank you. All right. Okay. So the interaction. So we want to support two different kinds of settings. One is how do we expect end users to interact with an IoT environment? Like that means actually interact with specific devices and specific sensors. And how do we want them to actually experience new environments? And so this has been embedded into the top 4 layers of our stack. Okay, so the challenges for interaction, these have been known for a really long time, at least 20, 25 years that people have been talking about these. So in an IoT environment where if you don't have giant tags or sticky notes or things stuck to devices, how do you know what's augmented in a particular environment? How do you know what you can ask of a particular device, even if you know it's augmented? How do you know how to interact with it? And so there's a difference between it has this particular function, but how do I access that functionality? And then back to the intelligibility question, how do you understand what the system is doing? These are 4 pretty fundamental questions about how we expect that users are going to have, a system has to support in order for there to be a positive user experience in an IoT environment. Okay, so we've been looking at a number of different modalities, and these are not all strictly modalities, but number of different modalities to enable people to interact with an IoT environment. I'm just going to jump right into it. So the first is not something I expect the average end user to be able to interact with, but something that we just started playing around with, a Python-based environment for exploring. I'm just going to jump right straight into the video here, which people on the line won't be able to hear. So I will try and talk over. Actually, there's no audio in this one. So this is our ThinkKit IoT environment. It's a scripting system. And first thing we want to show is how you can discover what's out there and interact with things fairly simply. So over here on the right, you can see what's on the screen. So he's already connected to the IoT environment. He can list what are the types of devices that are around me. So you can see a speaker and 2 lights. Then he can set. Let's speed this up, right? No, not in here. So he's setting just to a particular variable, so you can refer to it much more easily. And then he's changing the values of the sensors. So very simple command and control through a Python-based experience, which is great for a programmer, not a true end user. Here's where we start to get at the concept of the virtual actuation that I mentioned earlier. So again, here's the same set of devices. So he's telling all the devices to essentially provide some kind of notification. So something went red, something blinked, and I'm not sure what the speaker did because we have the audio off. Mm-hmm. And then how do you take that same system and then apply it to a different setting? So we want to be able to figure out, so I don't know if you noticed here it shows the signals, thank you, the signal strength to the other devices. So you can say, well, I want to talk to the device that's nearest to me. Whatever that happens to be, I might not even know. So in this case, I want to select the nearest light and use that to notify me. So just some very, very basics to start interacting with, and then you can bring it home, and the same notification just works. So they're very, very simple example of how to take rules from one setting into another. Okay. So if this answers the question of what's augmented, because you can just query the system to find out what's augmented. What can you ask? There's this query language built in. You still have to learn that query language. And that tells you also how can you ask these questions. So very structured environment to do some very simple things, but a nice way to start exploring the system. Okay. Okay. So we've also played around based on some suggestions from Max to some graphical systems to allow end users to build systems. So we built the equivalent of a very simple if this then that for our Giotto system. Right now it just supports simple Boolean rules. And so that's just actuation. Let me skip to the next one. So here we have this environment that we built in Node-RED. Node-RED is this IBM based visual programming environment for IoT environments. So our first block here, our first node in the flow is just saying how frequently you want this rule to check to execute. And so it's basically saying, so you choose a sensor, a comparator, a value, and then the actuation that you want to occur. And you can have any number of these. And then I think you can't see it on this page, but there's like 10 rules in this page for this particular environment. So we're starting to experiment with how users are actually accepting and how difficult this is for an end user. And it helps us answer the question of what's augmented, because what you can't see is so we're not showing here is when you drag this Giotto sensor over here, it says, here are all the sensors in your environment. So it's telling you what's augmented in your local environment. It's also telling you the kinds of things you can run through a graphical infrastructure. So the interface itself is constraining the kind of things that you can do and how to ask them. So it's fairly simple to use. We've also been looking at Blockly, which is a kind of jigsaw puzzle. You can see it over here on the right. It's an environment to build jigsaw puzzle-based interaction techniques. And so over here on the left, we can still do our Node-RED stuff where we're building this flow of data through our system. But then when you come to a particular node that's more sophisticated, we can jump into Blockly and combine them, which is we think will make it much easier for end users to interact with the system, but we're still developing this right now. It allows you to build much more sophisticated rules. Audio is one of the tougher systems or modalities to use with an IoT environment, mainly because, so I just got my Google Home 2 weeks ago, and I'm still trying to learn all the questions I can ask it, or not all the questions, but I can still try to learn what I can ask and what I can't ask it. So we have this system, we have an Echo in our environment, so we can have it start communicating with Giotto by saying, Alexa, talk to Giotto. I can ask what sensors are in my environment. I can ask about specific sensor values. So what the temperature, actually, what is the temperature in my office? Actually isn't talking to one sensor, but it's getting an average across all the temperature sensors if there's more than one. I can ask it for the state of different things in my office, like did I leave my window open? And then this other example of, do I have time to get coffee before my next meeting? Which is an interesting one, which I'm just going to zoom past in the video since we can't hear it. So here you would hear, Alexa, talk to Giotto. Do I have time to get a cup of coffee before my next meeting? And what it's really leveraging is information from people's calendars. I'm just going to pause that. It's leveraging information from people's calendars about who is supposed to be at that meeting, where is the meeting supposed to be taking place, what's the mode of transportation for all those individuals, assuming they've made that information available to me from a privacy perspective. What's their mode of transportation, how far away they are, with an estimate of how long it will take for everybody to get to the meeting spot. And then also see how far I am away from the coffee shop and the length of the coffee shop queue, and makes an estimate of whether I have time or not. So it either says something like, yay, you have time for coffee, and then I can ask for more details. And you would see, so this is just looking at the length of the queue. Here we have a little simulation environment where we can put different people in different spaces and change their modality of transportation. And so we can really easily sort of just play around with this. But one of the challenges with like I said, with audio is that there are no affordances in audio and based environments. Most systems that have been developed, most speech systems that have been developed, all suffer from the same problem. There's no way to know, other than through repeated use, the kinds of questions you can ask to a system. So you don't know what's augmented, you don't know what you can ask, you don't know how to ask those questions. So with my Echo, I'm finding even with my Home, I'm asking the same question multiple times in slightly different ways to get the answer I'm looking for. And there's no way to know what the system is doing when it's silent or when it has made a mistake. So audio is a real challenge, but given that we are moving more and more towards chatbots and audio-based systems, at least for personal assistants, it seems like it's still worth exploring. Another way that we've explored is through direct manipulation. So I know I want to interact with this projector. The easiest way for me is to just go ahead and take a picture of it. So here's a quick video. It's off. Okay, so someone shows up into a meeting room and forgot their printouts. So they're wandering around the environment and they pull out their phone and they take a picture of the printer because they don't want to bother installing all the drivers to print to that. So when they take a picture of the device, what happens is that photograph gets shared, it's getting broadcast to all the local devices around it. And each device is saying, is this a picture of me? And it's using a very, very simple SIFT-based technique to figure out what the number of matches between the image that was sent and the images that the system knows are of it. So the printer says, oh, hey, it's me, here's an interface, then it shoots an interface back and saying, this is what you can do to print a file, because that's what I know how to do. All right, so the printout's come out. All right, he goes back to the printer, and like most conference rooms, although we didn't have this problem today, you don't want to mess around with how to actually project to the projector. So what if I just took a picture of it, scans the environment again, shoots that picture out to all the local devices, and it says, oh, you took a picture of me, I'm the projector. Here, click on me to upload the presentation. And then on the user's phone, he has controls now to actually go back and forth from the slide from the interface that was delivered by the projector itself. Okay. So this asks the question of, this doesn't tell you what's augmented, because you can imagine people going around their environment and taking pictures of everything, hoping something magical happens. So it could be a pretty frustrating experience, but it does help you with answer the question of what can you ask and how do you ask it, because it shoots you the interface. All right. So we've also played with Google Now as an environment for pushing information to users. And so we're kind of thinking of most of Google Now is about, most, not all, is about the digital world, and we're trying to get these Google Now information pushes to be about the physical environment. So we built a system called Impromptu, which is looking at your local context and then figuring out what information, what devices in the local environment, what information, what services might be valuable to you at a given time. All right. So here's an example of an integration with Google Now. It's pretty simple. So this is obviously simulated. That's in a building not very far from here, I think. That our students set up last month here at Google. So someone comes to your door, they knock on your door. Stop this for a second. Someone knocks on your door, the camera takes a picture of you. If it recognizes who you are, it delivers to you, the person whose office it is, information about someone knocked on your door, and it tells you the name of the person who knocked on your door and the time that they knocked on your door. To the person who knocked on your door, if you're not available, and it also shows you a picture of that person. To the person who knocked on the door, they also get a Google Now card saying, hey, this is when Aninda's available next. Sorry, it's out of focus, you can't quite make it. So Aninda's free, or Andrew's free between this date and this date, between this time and this time. So it's just a very simple example of how to use private Google Now cards to deliver and push information to people based on the local IoT environment. Similarly, and a little bit more sophisticated, we've been using a system called we've been developing a system called Impromptu. I'm not going to skip the protocols and just jump into the app. So here you're able to leverage the local context acquired from the physical environment as well as from a mobile device, and have services pushed to you. So in this case, it recognizes that you're near a particular bus stop. When you click on the bus stop application, it provides you information about the bus that is right there. Now, it's a little bit more sophisticated than just location. It's actually making sure that you haven't been sitting there for a long time, or that you're not located in an office place right around that space, but that you're actually standing at the bus stop. So it uses a number of other features from the phone itself. Another one, I'm coming to someone's office and I want to meet with them, but they're not there. And so here, what gets pushed to me is, in this case, is the scheduling app for that particular office. So I launch it. And then I can basically see when that person is there or not. But the idea is that I don't have to figure out what apps are out there for me to use. The right app at the right time is being delivered to me. So here I'm back in the presentation room. Obviously, a projector is made available to me, but it also says, hey, I can also print these files for you. Another thing people will often do, and print or project my presentation.
Are you using image processing to do image comparison to determine what image it is?
So in this Impromptu system, no, but in the other system called Snap2It, where we were taking a picture, we are doing very simple image processing. SIFT, the 6-scale invariant feature transform. That's the extent of what we're able to do. We do use some more intelligence about location as well as orientation of the camera. So if I were taking a picture of the projector in that room and I could see the front of the projector, I know I could be on the other side of it. So we use that orientation information to filter down radically the set of possible responses. To the point where we're quite accurate at telling you what device that you've taken a picture of. If we have any ambiguity about which device, we provide you a list of the top choices.
And then you use rules-based to determine which device to narrow it down to. Is that correct?
So we use what?
Your rule-based system to basically go and determine which device it is, right?
Well, so we use SIFT and the orientation and the location to figure out which are the best matches. And if there's only one match that crosses a certain threshold, we just present you that interface. And if there's multiple really high matches, then we present you a list, and then you can go ahead and select the one that you want. So rather than picking from 50 devices, you're picking from 2 or 3.
Okay, got it. Thanks.
Yeah. All right, so here you don't have to ask for anything because things are pushed to you. You don't have to find out what's augmented because things get pushed to you. But then you introduce these other problems about figuring out, well, what's relevant in a given situation. And then how do you understand why the system pushed you information about Starbucks when you seem to not be anywhere near a Starbucks. All of the demonstrations we've given here all produce all the rule-based ones, all encode the rules in a particular JSON format that we've been developing, and they're right now shared at least between the graphical and audio. So any rules I produce in my graphical setting, I can replay and get access to through the audio interface and vice versa. And we're trying to do it across all of our interaction techniques. And so I can edit, and I have a seamless interaction no matter what the modality is that I'm using. So last slide, what we want to do next is really start to do what we want to do a while ago, which is to analyze more end users and find out what is it they really want to do, how do they really want to interact with these systems. We're not expecting that we're going to break a ton of new ground here because the HCI community has looked at this quite a bit. We want to look at how do you support better affordances, how do you let people know what they can do in a particular environment, and how do you have systems explain their own behavior. And we've been really interested in this idea of an app store for downloading. So both I can browse, so I'm installing an IoT environment in this conference room, and I want to be able to browse and sort of pick the rules that other people have produced. We also were looking on how do we push suggestions so it recognizes, hey, you just installed this environment. Here are things based on your configuration that I think might be useful to you, as well as this is how we see the space getting used, push this to you. And then we're also interested in how do I take rules that classifiers that are being developed for one environment and then transfer them to another environment.
How big of an issue is that particular point, just in terms of developing an
app store?
Yeah, the app store, and that, having something developed for one environment and then trying to apply it to other places that, because with phones, right, there's a very limited set of things that go on.
Yeah.
Are
you asking me how valuable it is, how hard it is, or whether it's worth doing? What's the question?
Where you see the particular, all of that, just in terms of why, how hard,
We think, so I can answer more of the questions better when we have our computer science building and showing the super sensors, because there we'll start seeing how things transfer from a conference room to an office.
Yeah.
I think it really depends on the complexity of the space. I think from an end user perspective, speaking as someone who uses their Amazon Echo a lot, the fact that I have to go and download and install these skills for every new thing I want to do, or for most new things I want to do, so it means I'm not doing it. I'm not actually being able to leverage 50% of what the device can do. So if instead we can have these things pushed and they sort of magically just work for me, the better. I don't expect any of the rules or heuristics to necessarily transfer very well, but if you combine that with the machine learning stuff we talked in the early one, then I think you have a pretty powerful system. And then the last thing is, as much as possible, we'd like to work with Assistant, because that just seems like a really nice building block to build a lot of this on from a end user experience. Yeah, that's it.
Okay, one question.
Thanks, you.
Yeah. So what you described as all the cool things you can do when it all works, it's really cool.
Yes.
I think all of our experience of building these particularly the multifaceted systems, lots of different things, is that something in that chain will fail.
Yeah.
What's your thoughts on how to tell the user what's happening, or give them some sense of what to go and fix or reboot or what?
Yeah. So I've thought about this less from the standpoint of a failure in a particular device as opposed to a failure in the classification. So I thought much more about this from a machine learning standpoint and having these systems explain their behavior. But I think the same thing would apply. So if it can, not that it would use this language, but if it could say, oh, we got no signal from this device, we took that to be a 0 value, therefore we made this decision. What's really interesting is that this device had a 0 value, which means it was off, or it was stuck in some weird state, or this value hasn't changed in a long time, so we just disregarded it and we made this decision. So I think here's where anomaly detection could be really valuable. Looking at routines or patterns within the data could be really useful to be able to use our existing intelligibility platform for machine learning, but apply it to this setting. The short answer is I don't know because we haven't actually done that yet.
Right. I was going to say, do you imagine proactively telling the user something? It's like, I've just turned the lights on for you with
80% confidence.
Yes. And so we found in our previous work that it's really important to tell an individual the certainty. When the certainty is below a certain level, it's really important to tell the user the certainty and provide an explanation of why you're making a certain assertion. Otherwise, you're more likely to lead to abandonment of your product.
Okay, I want to give the folks on GBC a chance to ask a question if they want. Otherwise, we are already a little bit over time. If you are inspired to work with the colleagues, reach out to me or simply put in a very short idea, a proposal for a collaboration with IoT researchers in academia at Go IoT-proposals, Go IoT-proposals. Are there any questions from GBC or another question in the room? Otherwise, I think we should slowly but surely wrap it up.
And is there an opportunity to go to lunch with these?
Oh, yeah, of course. By now, there should be some interesting demos set up outside the room. And we are going to have lunch in Kitchen Sink. So if you want to join us over there, it's